Hi, everyone. Good afternoon. Hopefully we won't have any issues today. So far, I haven't had any problems. So we're hoping it stays that way. But we're going to get started. A couple of things. First of all, don't forget, Monday is the official first day. So please make sure you are paying attention to homework due dates. So make sure that by end of day Monday, activity 75's homework is submitted. By Tuesday, 76 and 77. This one will be due on Wednesday. I'm also thinking about if perhaps I'm thinking about changing our schedule a little bit, and of course keeping the classes at noon. But hi Jake. But instead of having the classes at noon Monday through Friday, having them Monday through Thursday, and then Friday will be your day just to do your assignments. Make sure that any assignment is up to date. So, hi Coop. So I'm thinking by, Monday through Thursday, and then come Friday, you guys do your homework, and that's it. So we'll only meet 4 days a week. The activity questions for this one that we're doing today is not on Edsby yet. I had so much fun with the internet yesterday that I didn't actually get on Edsby until much later in the evening. And that was to actually put notebook grades in. Now, no, I have not finished all the notebooks. So before everyone's like, oh my God, activity 75, 76, and 77 have been there. Activity 78, I'll be putting in today. So guys, be nice to each other, please. Friday, your job will be to log in and to make sure that you do your assignment that is due by Friday, and that way you'll have no homework over the weekend. So Monday through Thursday classes. Okay. Today we're meeting, obviously, excuse me, today we're meeting because we did not have class yesterday. So Friday could be a potential makeup class for any class that we missed because we're unable to string. All right. So, hi, Iman. Hi, everyone. For those of you that I didn't get to say hello to, hi, hope all is well. I am grading notebooks. I got a very large chunk graded and put in Edsby already, but there's a lot of you. If you did not turn your notebook in, please send me a private message and I'll be getting in touch with you. I've just been trying to make sure that I get everything graded so that come Saturday, I can get in touch with you and let you know that I don't have your notebook. I just want to finish all of the notebooks first. Then I'll get in touch with whoever's notebook I don't have and schedule a method to grade it. So I have a couple ideas out there. I will talk to each person individually and figure out the best way to get their notebook taken care of if it was not turned into me. Okay, so just, if I haven't gotten in touch with you yet, like I said, I'm just trying to finish what I have early so that I can catch everyone who I don't have. So be patient. I will be getting in touch with you by Saturday. Okay, I don't know. I graded over 100 notebooks in the last 2 days. So I don't remember the names. So I've got my pajamas and mine says hit snooze twice. So now, we're going to go ahead and get started with the lesson because it is Friday. And since it's Friday, I know we want to, finish up early so we can begin to enjoy our weekend. All right. Yeah, I've been on a notebook grading roll. I graded between yesterday and the day before, I graded over 100 notebooks. It was insane. But I wanted to get them done, and I finally had to just walk away from all these messages that I was getting and just focus on making sure that I took care of grades, because it's just been between meetings and messages, it's been a mess. Aiden, Jake says hello. He's one of my students and he saw you pass by. So, All right, so I'm gonna start on activity 78. Now, I did send you pictures of all of the activity 78 pages in your EDSB. So check EDSB, you'll see everything, including the questions are there. So in previous activities, you learned about force, mass, and changes in motion. In this activity, you will investigate the precise relationship between the mass of an object, the force applied to it, and the object's acceleration. You also learned earlier that scientists measure speed in meters per second, and they measure mass in kilograms. In this activity, you will need to know standard international units in order to measure force and acceleration. Acceleration is a change in speed measured in meters per second divided by time measured in seconds. And so the unit for acceleration is meters per second, or meters per second squared. Now, you may have remembered me talking about this. I actually have a previous YouTube stream on this as well. Video. I did talk about that before. So just make sure you're paying attention to some of the old videos talking about, I think we were talking about kinetic and potential energy at the time. Okay, so force is measured in newtons, and this unit is named after Sir Isaac Newton, who's a scientist who studied force and motion. I would prefer not if you can avoid it. Again, EDSB, especially yesterday, EDSB was a hot mess. I would wait until closer to the end of the week. And if you continue to have a problem, let me know. But there shouldn't be an issue. It could be the time that you're doing it as well. There tend to be a lot of people on EDSB during the day before 4:30. I would wait till after 4:30 to submit if you can. So I don't know when report cards are coming out. I know our grades are due to the district by noon on Monday. So since our grades are due to the district noon Monday, I presume they're going to do whatever they do. For past activity 76, I would rather you submit it directly in EDSB, because if you send me a Word document, I'm going to have to go through emails to try to find people's assignments, and I don't want to miss someone's. That's why I'm setting it up so that you could submit it directly in EDSB, because the grade book actually notifies me that you have an assignment that's submitted to be graded. If you send it to me in a message, I may not necessarily see it, or it may get lost in a sea of messages. Analysis questions are done in EDSB. It's currently marked as a test, but it's not a test. It says it's going in the homework column. So it's going in as a homework grade. For some reason, the only way to schedule anything that is online is as an online test. So what you can do, Cooper, is, oh yeah, that you can submit. If you go into the assignment, Cooper, you can actually press 75 and upload the Word document, because I didn't do that format for 75. Okay, does that make sense? If the notebook is graded already, it'll be in your EDSB. Every single notebook that I've graded so far, I put in, but I still do have some more notebooks to grade. I'll be working on those later on this evening. So I'm trying to get those done no later than tomorrow morning. So don't worry. All the notebooks that I have in my possession, the grades will be in by tomorrow morning, and anyone whose notebook is missing, I'll be getting in touch with them. Okay? All right. So moving on. So part A, graphing the variables. The table below shows precise measurements from an experiment in which a force is applied to a pull block along a frictionless track. So it says use experiment 1 data to make a graph of the relationship between acceleration and force. So this is the data table that they were talking about. Okay, so this is the data that we're supposed to be making a graph of. Again, I sent you a picture of this. Now, my recommendation for these graphs, to make sure you're doing it correctly, is I suggest that you go into, on a piece of paper, You look at the data information. Again, I sent pictures of this on Edsby, or you can pull up your online textbook, make a graph of it, then come back and compare it to a graph. Okay, compared to the graph that I have. Okay, so sorry about that. So I'm going to do this graph for you here, and you're going to see what it looks like, and then I'll show you what the answer key looks like as well. I just want to make sure you understand how to actually do the graph. Okay, so we are graphing force, acceleration, and the mass of the block. So we're graphing acceleration versus force. Okay. Now, for the first one, if the force is 4 newtons and the acceleration of the block is 2 newtons, you're going to have a dot here. Okay. Guys, all right, guys, the commentary needs to stop. Now, the second one, the force is 2 newtons with an acceleration of 1 newton. Okay, the next one, the force is 20 newtons with an acceleration of 10 newtons. And the last one, the force is 10 newtons with an acceleration of 5 newtons. So we can see that this forms, I don't have a ruler in front of me, so I apologize, but this forms a relatively linear line. Can you give me that blue marker? The blue. So now, is everybody following so far? Does that make sense? I know my line is a little off because I don't have a ruler. Why is Bella here? So, oh, okay. All right, so analysis questions, you can go back as you practice the graphs. Okay, you can call her name and take her. Okay, part B, use experiment 1 data to determine a mathematical equation that shows the exact relationship between mass, force, and acceleration. Record the relationship in your notebook. So try adding, subtracting, multiplying, and dividing to see what measurements you get to get the third. So looking at this, you have a force of 4 newtons. Now I'm reading this backwards, so bear with me. A force of 4 newtons, a mass of 4 newtons, and an acceleration of 1 newton. Okay, so if you want, you have to create a mathematical equation. So the mathematical equation, you can look at it a number of ways, but if you have force is equal to mass times acceleration, 4 is equal to 4 times 1. Okay? Now, force, she doesn't want to go in. All right, then just leave her. Just leave her. Force is equal to mass times acceleration. 2 is equal to 4 times 0.5. 20 is equal to 4. I'm having trouble seeing. Times 5. And 10 is equal to 4 times 2.5. Okay? So does that make sense, guys? How you created that? Now Gabby said hello. No, it's force is equal to mass times acceleration. Now, if you wanted to, if you were, let's say, instead of solving for force, you were solving for mass, okay, then it would be force divided by acceleration gives you the mass. Does that make sense? Okay. So and I believe I showed you this equation before we left, but force is equal to mass times acceleration. So I'm going to go get another dry erase board so we can go ahead and I can actually show you the equation. Pass me the eraser, please. Okay, so thank you. So force equals mass times acceleration. That is the formula. Okay, so if you're looking here, the first one is 4 is the force, 4 is the mass, and 1 is the acceleration. So 4 newtons is equal to 4 kilograms times 1 meter per second squared. Does that make sense? Yes, no, maybe so? I know Ella was having concerns. She said she was lost. Okay. So if you needed to, let's say, rearrange that formula to solve for mass, okay, force equals mass times acceleration. So if I wanted to solve for, let's say, mass, I divide by acceleration on both sides to isolate the mass variable. So force divided by acceleration is equal to mass. So if the mass is 4, according to our graph, the mass is, which one was I looking at? All right, let's look at the first one. Force is 4, mass is 2, acceleration is 2. So force is 4, acceleration is 2. And in order for that to be true, mass is 2, which is what you're getting here. Okay? Is that good? All right, so moving on. So for part B, we just found the equation. So part C, the data table below shows measurements from experiment 2. See whether your equation works for this set of data. Okay, if it does, go on to step 6. So we have experiment 2 now. Oh, that's what we were just looking at. That's why I was confused. If we have experiment 2, we have to look to see if our equation works for experiment 2 as well. Okay, so 4 is equal to 4 times 1. 2 is equal to 4 times 0.5. So we actually looked at experiment 2. Experiment 1 was the same thing. 4 is equal to 2 times 2. 2 is equal to 2 times 1. 20 is equal to 2 times 10. And 10 is equal to 2 times 5. Okay? Yes, you divide force by acceleration to get the mass. That is correct. If you were finding acceleration, then it would be force divided by mass would give you acceleration. Does that make sense? So basically the same thing that I did here. Instead of dividing by acceleration on both sides, if you're solving for acceleration, you would divide by mass on both sides. So it would be force divided by mass would give you acceleration. Okay? Okay. And I can also post a brief YouTube stream, not stream, but a video just going over how to do that to help you guys out with that. Okay. Now, look at your graph line for, oh, I have to graph experiment 2 now. Okay. So if we're graphing force and acceleration, force is 4, acceleration is 1. Make sure I did my graph correctly. I want to make sure I have my units to my graph. Okay. And then we have force is 2, acceleration is 0.5. And then the third one is force is 20, acceleration is 5. And the last one is force is 10, and the acceleration is 2.5. So this is our graph here. Okay? Does that make sense? Huh? Now, okay.